If you love space science and astronomy news, check out my 60-second short videos every weekday. In case you missed them, here's all the daily videos in one cut. There was a ton of great stories this week, but of course there's a ton more out there just waiting for you to discover them on your own. Did you know astronomers are detecting more and more gigantic galaxies many times the size of our own Milky Way? We used to think such galaxies were relatively rare, but now we're having to rethink what we know. Researchers using South Africa's Meerkat telescope just spotted a radio galaxy 32 times the size of our own Milky Way that they've named Nkathazo, which means trouble in the Zulu and Xhosa languages. Why is this galaxy trouble? Because we have so much difficulty explaining the physics going on within these massive galaxies. They have huge jets launching plasma millions of light years into the space around them, and these jets glow brightly at radio frequencies, making it easier for telescopes like Meerkat to spot them. Nkathazo contains several mysteries. Its plasma jets are bent rather than straight, and it lives inside a cluster of galaxies when astronomers had previously thought that such galaxies lived in isolation. Meerkat is a smaller radio telescope array that's a forerunner of the Square Kilometre array that should come online in the late 2020s, and the SKA will hopefully allow us to dig even deeper into the mysteries surrounding these galactic behemoths. Our understanding of how the universe formed and evolved seems to be missing some important details. New observations of Type 1a supernovae in the Coma cluster and data from DESI, or the Dark Energy Spectroscopic Instrument, have produced a value for the expansion rate of the universe with very small errors. That value of roughly 75 kilometers per second per megaparsec disagrees with the value of 68 kilometers per second per megaparsec that you get by using the cosmic microwave background and a cosmological model. If everything was working as intended, those values should be the same. You can think of the supernovae as starting from now and going back in time, and the CMB method as starting in the early universe and working your way forward to today. As an observational science, it's pretty common in astronomy to have models that are around for a while, then technology improves and we're able to make better observations that contradict the models. What's wrong with our model of the universe and how it might need to be changed to account for the observations is still very unclear, but it's super exciting to see that there are still some surprises left for us to discover. The paper with the latest results is published in the Astrophysical Journal Letters on January the 15th. If you're interested in learning more about the Hubble tension, check out my Patreon where there's a longer video for members. Are you ready to see the most detailed view of the Andromeda Galaxy ever? This stunning mosaic of the galaxy is the largest created from Hubble Space Telescope data. It's composed of roughly 600 different overlapping fields and captures 200 million stars in our neighboring galaxy, representing 10 years of effort. This incredible image is not just amazing to look at, it contains details that will help astronomers explore the mysteries of galaxy formation and evolution. For example, Hubble measured the intensity of light at both ultraviolet and optical wavelengths for over 90 million stars in the image. One thing astronomers are eager to explore is the merger history of Andromeda. In addition to a bunch of mergers with smaller galaxies, there have been suggestions that the southern half of Andromeda experienced a major merger 2 to 4 billion years ago. A mosaic of the northern half of Andromeda was completed in 2015, and now with the addition of the southern half, astronomers can compare directly to test what mergers we think Andromeda has experienced during its life. The results of this research were published in the Astrophysical Journal on January 16th.